Hi, this is Miss Linton. It's my wonderful Period 1 class. Say hi.
Hi.
Okay, so we're going to do the first part of this lab today, which is setting up our slides to look at the stomata on the underside of the leaf. And the reason why I'm talking about this now before we finish our discussion is so that you can pass around the fingernail polish to paint your leaves, okay? I made 2 quick slides just on 2 local leaves that I got from right here at Oak Park High School. And I painted them. I probably let them wait like maybe 15 minutes. Made the slides, checked them. They both were like perfect. And I mean, I did not invest, you know. I mean, I went quick and it works out really well. I just want to give, I don't want us to be all fighting for the fingernail polish when we're done with the lecture. That way we can pass it around during the lecture. Does that make sense? Okay, so I'm going to have you get in your lab teams in just a minute. Now that you've had a chance to do the background, let's talk about a couple of things. This is what you're after, and you're going to count up individual stomata, okay, each opening, and you need to do that on the highest magnification. And then remember I said we would go over how you can find the area of what you are looking at so you can calculate the number of stomata per centimeter square. So what you want to do is, I'm going to have you in your teams. I want you to just, so you can do some comparison, do 2 different leaves. So half your team is going to do a monocot leaf and half of your team is going to do a dicot leaf. And right out here, we have wonderful examples of monocots and dicots. The monocot leaf went by. My dicot leaf, I just got one of these, okay? And they're just right out here. And then the monocot leaf, I got right here. And you know how to recognize a monocot, right? Okay. So then I went to the underside. I actually didn't wash it and dry them. I went like this. It's possible, I mean, you know, yes, what I did. And I said, okay, clean. Okay. Then what I would recommend, because the fingernail polish is really clear, is take like a pen and make an area where you're going to paint the polish inside. And you don't, remember, you're on the highest power. It's not like you need to like paint the underside of the leaf. You just need just enough that you can see where it is in order to pull it up. It's a very tiny spot, okay? And so I just went brush, 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 and said, duh, okay? And I just let them sit there. And so again, on your leaf, it's the underside, and on this one, make sure you're on the underside, okay? Then you will let that sit, you will let it dry, and then the key part is using the right kind of tape, and you have to use, you know, like some tape is clouded on there, you can't have it, so this is the right tape back here that I have in this jar, it's clear tape, and you just need a little piece, and rip it off. Okay, and then here's my strong suggestion so you can clean your slide off better. Okay, make a little, see now if I put my hands all over it, can you see where my fingerprints are now? So don't do that, okay? So careful, be better than I am, all right? Take a section and fold it back on itself. That way when you pick it up, you have a little hand hold place, and when you try to get this tape off the slide, it's way easier if you have a little handle to pull it back off your slide to clean your slide, okay? Then you're just going to take this tape, you're going to put it right over your fingernail polish area and just push it down firmly, you know, make sure it adheres, but you know, you don't have to, okay? And then all you do is you just rip this right off, and you will see a little patch right there of where your fingernail polish is. Then you will take this, you will take a clean slide, is always best, you don't need a cover slip or anything. Take a clean slide and you're just going to stick it right on there, like that. And then you'll be able to see it underneath the microscope, no problem, okay? And then when you want to clean your slide off, you can do that instead of, you know, instead of trying to peel it off the edge like I'm going to do for this slide, because I forgot to do that at the time and I was late for my nail appointment, so I was like, yeah. I'm just checking it. So anyway, just so do that, and then you will each do at your team, one of you a monocot, one of you a dicot, and you'll do your counting, and then talk to somebody else when you're doing your area. See if you're coming up with the same values, and I'll make a course shared data chart where we can compare between the two different species how many we can count. Okay, so that will be that part. Again, when you want to calculate the area, we can't measure on high power the diameter of the slide in order to calculate the area. So we'll measure it on low power, the diameter of the slide, and I have rulers, I'll set them out right up here up front, and that will go thin underneath the microscope, and then you can do it on low power. So if you know the diameter on low power, and if you look at the differences in magnification, you can cross multiply. Low power magnification is 100, high power magnification is 400. How am I coming up with that 100 and 400, by the way? Yes?
The 10 is from the eyepiece?
Yes.
And then the other part is from like the main...
The objective lens, exactly. So low power has a 10 on it, so 10 times 10 is 100. High power has a 40 on it, 10 times 40 is 400. What's 100 divided by 400?
0.25.
So whatever the diameter, based on just magnification, whatever the diameter is, right? So if it was, it's not, but let's say it was exactly 2 millimeters across on low power, right? If I take 2 millimeters, I know that high power magnification is only 25% of that. So it would be what? 0.5. That's all you need, okay? Once you have the diameter, you can get the radius. How do you get the radius? Just divide it in half. And then to get the area, pi r squared. So half the radius squared times pi. Now we know the area, okay? And then you can tell me, then we can make comparisons. So, and those are all explained on your chart. You can do that. We have a, and here as well, we have a, so you're going to look at 3 different areas on your underside of your leaf, get your average number, and then do your calculations. You have to multiply it by 10 so we can get it into centimeters. Okay. First. Okay, then we are on Thursday are doing another discussion lecture. Okay, we have something planned, but then on Monday, don't forget to sign up as a team once you've established who your team is. Don't forget to sign up and say whether you're coming in at nutrition or lunch on Monday and Wednesday. We have class on Tuesday and Thursday. And then what you're going to do, and we need to identify which variable you want to do. I'm going to have a set of plants that are going to come from a nursery that I'm going to go buy the night before. And and what you will do is you'll pull out a plant, and get all of its roots, okay? And then you will bag the bottom of the roots with baggies that I will have out. And this is a little overdone here, but I just wanted to get you a picture. And you'll put the roots in the bag, and it's very important that you kind of take the top of the plastic bag and seal it around the base. Maybe use a little tape in order to do that. And why is that important to seal that? Water loss. You only want the water loss to be coming through the stomata, the openings in the leaves. You don't want it to evaporate from the base that way, because you're going to take your initial mass at that point, and then you're going to be taking its mass every day for the next 3 days following that, and you want the only change to be what came out through the leaves. And we are saying that if it loses 1 gram of mass, that is equal to 1 milliliter of water. Okay, we lose 1 gram, that's equal to 1 milliliter of water. And we're putting our plants in different conditions so we can make comparisons. Okay, your sister lab group, 1 and 2 are sister teams, 3 and 4 are sisters, 5 and 6 are sisters, and sister chromatids. Held together by a centromere. Yeah. Separating during anaphase. And then 7 and 8 are sister teams. You're going to have a control between you. So you'll have to do one other plant that is a control that you will share with that team. When you keep your plants in your baggie, it might flop over. So you can, however it works best, if you want to just measure it in your bag, you can, but I would probably mass it in a cup. And so these are cups left over from other classes. You can put a tape label on it and then use that to kind of support your plant while it's sitting there. Okay. And again, the conditions that we have, I have them right here. You have a fan okay? And we will set up a fan at table 2 and table 7 probably will each hold the fan. And then everybody who's doing the fan will do it at the, or we'll see who's fan. We'll do that first, then we'll decide. We'll just have one fan on one side of the room and one fan on the other side of the room, and then we need to share the area so that everybody is fanning equally and having the same impact. Then whoever's going to be doing light for 24/7, we're going to set up a couple lights back here, put them in the window, and then also shine lights right on them back here in the back of the room. And the rest of you are just going to have whatever light is on during the day, okay? But the light people will put you here in the back. Controls we'll just leave between your lab stations, one on one side of the sink maybe and one on the other side of the sink for your controls, and you can each mask those when you come in at that point. And mist, remember you're going to put a baggie over the top, and then you'll spray in there, starting after your initial mask, you'll spray one time, and then after you mask it each time, you'll spray it again. You don't want it to be so wet, though, that it keeps adding to the weight of your plant, okay? But every day you can spray one more spray after you mask it, okay? Then we will take our mask and then do your changes, and this part of the lab where we add it all up, this is going to be next Thursday when we do the completed part of it, okay? What I'm going to be checking for, the next time I'm going to check your lab notebook is next Tuesday. That's what's on our schedule in class, okay? And that's when I want to see everything up through this point. You couldn't do that part yet because you didn't know what your hypothesis was, because you didn't know what your variable was. But by next Tuesday, I want to have it up to this point, okay? And then we have time set aside on Thursday then to finish up the lab. Okay, so let's go ahead and I'm going to have you quickly move into your lab stations so that we can pick our Flava Flav and decide who's doing the monocot and who's doing the Unicot. And I'm going to go ahead and stop it here.